Okay, here you can see, yes, here you can see a schematic diagram. So on the basis of the following schematic diagram, choose the correct statements. So here we need to find the correct statement. Yes, and here you can see the S1 and S2. Here you can see the S1 and here you can see the S2. Those two are foliations. Here you can see there are two foliations, S1 and S2. Yes, S2 is there, X is there, Y is there. Okay, and we have four options: mineral X and Y, predate, matrix foliation S2, predate, okay, not the word. Then B, mineral X grew faster of development of matrix foliation S2, okay. Mineral Y grew during or after the development of internal foliation S1, okay. Mineral X and Y post-date matrix foliation, okay. So this is a formation of a foliation, or it is a formation of a crystal in a foliated plane, okay. So now here we have the image, that is tectonic image, that is pre-tectonic, syntectonic and post-tectonic. Here you can see the images. That is, this image indicates how the crystal formed. Okay, how crystals formed in various processes, that is in the pre-stage, during the deformation, after the deformation. So before deformation, during deformation, after deformation, how the crystals will be oriented or how the foliations will be present. That is image shows. Here you can see, here also you can see how the changes, and here also you can see the changes. That is pre, during and post. That is pre-tectonic, syntectonic and post-tectonic. Okay. Now here you can see the S1 foliation. The S1 is the first foliation. This is the first foliation, and that is due to a particular deformation. Actually this S1 foliation occurs due to a particular what? Deformation, and that is the first deformation. And S2 is formed after that. Okay, this S1 may be formed of metamorphism, and S2 is formed after the formation or the deformation of S1. Now there are two crystals, X and Y. There are two crystals. Now we have to observe the texture, size and shape of this foliation. Now we should observe the size, texture, here you see a texture and shape of this foliations. Okay, so now see the image. Here the pre, post scene, everything is present here. Okay, so now here it is formed. Here you can see three crystals, whether it is formed during the formation or it is after the formation or it is present or during the formation. Okay, now option A. Now there are two crystals. Now let us see what is this option says. First is mineral X and Y predate matrix foliation S2. Okay, so predate, that is pre means here you can see it will be formed like this, predate. Why? Because it is before the deformation. Okay, so it is predate. Here you can see the foliations is, that is everything is present inside this crystal. Here you can see, isn't it? So what? In S2 it is not predate. So option A is wrong. Why? Because it is not predate. Because if it is predate means it will be like this. No impressions will present inside it. But here you can see the S2 is clearly present inside this crystal, isn't it? As there is no change before and after. You can see there is no change before and after. So we can conclude about the predate matrix. Now second option is that, now option B, mineral X grew after the development of matrix foliation S2. Now for X grew the development of metric foliation, option B, that is crystal present, crystal is already present and the deformation takes place, that is in crystal Y. Now you observe in crystal Y what happened. Foliation can see, here you can see the foliations, isn't it? This foliation can be seen. So how it will be? This option B, that is mineral X grew after the development of matrix. After the development of the matrix, what will happen? This X will grow. So this is completely correct, isn't it? We can observe from this figure. Next is mineral Y grew during or after the development of internal foliation. So internal foliation, here it is not like this. Why? Because why? Mineral Y grew during or after the development of internal foliation. Yes. Why? Because here you can see internal foliation. After that, this S2, here you can see it is present, S1 is present. That is after this formation. So Y grew during or after the development of internal foliations. At the same time of internal foliation or after that. Here it is. Isn't it? So what will happen? This statement is also right. Then option D is mineral X and Y post-date matrix. Post-date, it will be post-tectonic. But here there is no post-tectonic present. Isn't it? So this is also wrong. So the answer for this question will be, but for A it is half correct. Okay. And for this also it is half correct, but the statements are not fully correct because matrix X and Y post-date matrix foliation. Why? Because here it is like that, but Y it is not like that. So both A and D are partially correct, but they are not completely correct. So the correct options will be B and C, whereas A and D will be partially correct. So this will be the correct answer for this, B and C. Okay. Yes. Now the next question. A marine organic rich black shale. It's a black shale with tiny pyrite crystals show complete absence of body or trace fossils. Which one of the following statements is or are true? We need to find which of the statements are true. And here we have the 4 options, right? So now we need to know whether it is right or not. Okay. So the first statement is the sediment were deposited in low energy conditions. As we know, in low energy conditions, what clay or clay-sized sediments will be deposited. So sediments were deposited in low energy conditions, and it is organic rich black shale. So it is clay rich. So option A is correct. Why? Because in low energy conditions, these sediments were deposited. Of course, it is correct. Then option B, the deposition took place in dioxic to anoxic conditions. Dioxic to anoxic conditions. So how we can check this statement is right or not? Here you can see a marine organic rich sediment. So it is always dioxic to anoxic conditions the depositions may take place. So now this is also correct because it is given that it shows the complete absence of body or trace fossils. So that option also will be correct for this statement. Third option, the rate of sedimentation was very high. Yes, of course, the rate of sedimentation will be very high. It's a usual thing. Why? Because sediments are deposited. Then finally, the environment was stressful for survival of living organism. Yes, by absence of body or trace fossil. So we can say that the environment is not fit for living organism. This statement is also right, and these 4 statements. So now we see this 4 statements supports the main statement. So both this A, B, C and D. So all these are correct and which supports the main statement. Okay, so all these options are correct and all these 4 options try to convey best of this main statement. Okay. Yes, so moving to the next question. Yeah, this is very direct question. Here you can see the formulas. This is actually given. Okay, this is the given: spinel, magnetite, chromite, ilmenite. What we need to know is that we need to identify which is having the chemical formula AB2O4. AB2O4. We need to identify. So for that we need to know the chemical composition of all those things. Then only we can easily identify those things. As we know, spinel, magnetite, chromatite, ilmenite is very important materials. So as everyone knows its chemical composition. Okay, so without any doubt we can easily find. Okay, so first of all, spinel. I have already given the chemical composition of spinel is magnesium aluminum oxide, MgAl2O4. That is MgAl2O4 is given. Okay, then next is magnetite, that is Fe3O4. Okay, this is wrong. Next is chromite, FeCr2O4. Okay, that is MgAl2O4 is right and FeCr2O4 is right, then eliminate it is FeTiO3. So this is also wrong. So option A and option C are right. Both these are having the general chemical composition Ab2O4. Okay, spinel MgAl2O4 and chromate FeCr2O4. Okay, yes. Now to the other question. Okay, now here is the next question. Okay, and which among the following statements is or are true? Okay, now here there is 4 statements given. What we need to do is that we need to identify whether these statements are right or it is wrong. Yeah, so let us see about the first statement, that is about attrition. Attrition is more dominant in aeolian than in glacial environment. As we know, attrition, it is nothing but when some particles moves in water, what happen? These will collide each other and this will erode. When two boulders or two particles are moving together, they will collide and they will erode. That process is known as attrition. And now it says that attrition is more dominant in aeolian than in glacial environment. Yes, the statement is absolutely correct. Why? Because as we know, in glacial movement it will be packed, separately and there won't be much attrition process, and there won't be any prominent erosional features, or erosion also won't takes place. But in the case of aeolian, it is more prominent, attrition is more prominent. So we can say attrition is more dominant in aeolian than in glacial environment. So the statement 1 is very correct. Okay, this is very true statement. Now option 2, centrifugal force drives the sediment laden water outward when the river channel meanders. Centrifugal force and meanders. Yeah, now let's see the image. Meandering is something like this. Here meandering, it will be something like this, meandering of a stream occurs. As we know, it will be semicircular portion or circular. So when the water flows, it will be coming like this. This will be the water flow, isn't it? This will be the water flow. As you can see, this will be the water flow. Okay, and here the sediments will be deposited. Both the sides, the sediments will be deposited. So since we know it is a circular path, what will happen in circular? That is, in this middle portion, this will be. So the water flowing in a circular direction. Now we can see the water will flow in a circular direction. Hence it is influenced by the centrifugal force. As we know, the circular path is, or the circular direction is always affected, or it is circulated by the centrifugal force. So the centrifugal force is related. So this statement is correct because meandering of streams will follow a circular path, hence centrifugal force derives that, and the sediments will be deposited in this region. So the statement is correct. So statement A and B are correct. Now we have other 2 more statements. Next is, U-shaped valley is a common fluvial geomorphic feature. We need to find, that is, U-shaped valleys. There are various valleys. U-shaped valleys, they are fluvial geomorphic feature. Of course, as we know about the prior knowledge of geomorphology, the statement is wrong. This is completely wrong. Why? Because U-shaped valleys are not originated by fluvial, whereas this is V-shaped valleys. If the valley is V-shaped, it is formed by fluvial. It is not U-shaped valleys. Okay, U-shaped valleys are not fluvial, but V-shaped valleys are fluvial. So this statement is completely wrong statement. Okay. Now, 4th option. The downstream water velocity in a river channel increases upward from the channel but towards the water surface. That is, the downstream velocity. Downstream water velocity in a river channel, if it is okay, what will happen? Yes, that is, channel increases upward from the channel bed, from upward. Yeah, so the best option serving this is, you can see this image, that is the depth versus velocity profile. Okay, here you can see the distance, it is given in feet, and here you can see the velocity feet per second. Okay, here you can see various mean velocity, 16% of depth, and here you can see the greatest velocity, and here is a zone of velocity loss. Here is gain and here is loss. Okay, now here you see this portion, that is a profile. We can find that the minimum velocity is present at the base. Here you can see the minimum velocity is always on the base, that is the bed of the, here you can see as the bed. Okay, in the water bed the velocity will be minimum and velocity will be increasing towards the top of this bed. So this portion velocity will be minimum, sorry, velocity will be maximum, and velocity will be minimum in this portion, and it will increase towards the top portion, and here the velocity of the water will be increased. Okay, now here this distribution table also you can see, here it is going, and yeah, in this area here you can see slight difference, and then it is slightly increasing. So as we can say that the water velocity is increasing from this very low or downstream, in a downstream velocity, that is river channel will increases from the bed towards the water surface. So this will be correct. Okay, so this statement also will be correct. Why? Because it is decreasing from, or it is increasing from bed to bottom, so top. Okay, yes.